Hey there, Paul. A little bit of background. I've been in the construction industry for about 30 years now. Well, actually, it's exactly 30 years now. And I joined Masonry Structural Coalition about 5 years ago. And so far, in the last 5 years, I've done a little over $100 million and assisted with over $100 million in masonry projects. So really, this is all about you guys. Anything that we can do to help with any of your masonry, wall systems, any of the projects that you might have going on. Bruce is in the back there too. Everybody knows Daryl there. So if you ever have any questions on anything, any of your projects, you can certainly call up, whether they're technical questions and structural, or if you'd like for me to do some pricing for you, I can do that. So what is the MSC? The MSC actually started a lot longer than I've been here. Daryl was part of that with Dave Gillick a long time ago. So they kind of put it together and thinking, how can we get out there? How can we offer services to the architects, structural engineers, contractors to figure out and deliver accurate information about masonry wall systems and pricing. When we were putting this together, this program together, I know it's compliance, components, and cost, but really we should have done it the opposite way and done cost, components, and client. Because everything that we do and we want to bring to you it's got to start with pricing. So when you see and I run through this project that we've done before, you'll see the pricing that we have, the budget pricing is always up front. Because I don't know anybody other than maybe my son and wife that don't care about what something costs, Is that right, dude? Yeah. So we want to start with the pricing. Really take a look at that because, a lot of times we hear, architects just, sometimes I don't think you have the access to the pricing systems like we do. So we're going to try to help you out with that. Also, it's not like it used to be. Architects just don't have the time to compare different wall systems and compare the pricing on that. So we can take a look at that and walk through each of your projects with you, whether it's from early on or to value engineering, to help you get the right pricing and to figure out which wall system is the best for your project. So when does the MSC get involved? Well, it's never too early. We always say that as early as we possibly can because it makes it a lot easier to help you with your projects if it's early on. So we can do that from anything from a footprint, a little sketch, hand sketch. I've actually put together some just basic designs of a footprint. So we can help you really, really early, and it's better for us to get involved earlier. If we're in the pre-design of the program and schematics, we can put together wall assumptions for you. We just need to talk through a few things, talk through some heights. We need to talk through, what you're looking at in a building, what kind of building is it, what is our code compliance. So anything we need to get, the first thing that we would start doing is with identifying the controlling documents. This is pretty typical of what we would be looking at right off the bat. IBC, IECC, I have the 2021, but I believe we're 2024. Is that correct? I think that's the most current version. But I just have the 2021 up here. The ASCE 716 I show up here. I think that right now is the 22. And then we've got the TMS 402602. And then we've got the thermal catalog. I don't know if you've ever used the thermal catalog before. If you haven't, it's a great source for figuring out your energy compliance and your R values. And then also I've got the ICC 500 that we take a look at if we're designing storm shelters. And then the P361 I don't have up there, but that would be another one. If it's a FEMA funded storm shelter, we would look at that information. So wall assumptions, this is something that we would do right off the bat. These are actually wall sections that are taken out of tradesman software, which I'll talk about in just a little bit, but these are wall sections on a particular project that we had. So I'll kind of run through these with you. We go with the wall heights here. That was one of the things that were very early in on the project. We can talk a little bit about that. What type of structure is it? So we've got our wall heights listed there. Our CMU structural backup, this particular one was an 8-inch CMU wall. Then our veneer. You know, if it's really early in the project, you probably don't have that veneer or material picked out yet that you want to use, but we can give you several options, whether it's a 4-inch masonry unit, or maybe it's a utility brick or a modular brick. This particular one was a modular brick that we have here. We've got a couple of different wall systems here. We've got our 4-inch cavity. So we've got, which is our 2-inch XPS, our insulation, and then 2-inch airspace. And our bottom of the wall, our mortar net, flashing, and weak vents at the bottom of the wall here. So this just lays everything out. When we do these projects with you, we're actually going to send you a copy of the PDF, so you'll have all of these different wall sections that you can use yourself, or you can show it to your client or who you're working with, the team that you're working with. Vertical reinforcement isn't shown in the wall, but with this particular job and this particular wall, we had one number 5 at 48, and then for our shorter walls, we had our shorter walls, one number 5 at 48, and our taller walls, we did one number 5 at 16. For horizontal bond beams, we'll actually put these bond beams, and it's based on several of the things we'll talk about here soon, but we got 2 number 4s at 10 and bearing at a top of wall, so you can see, and we do those different color coded so you can see where we actually have the bond beams in the wall. And when we show you that modeling of the full project, you'll be able to see that around the building of where the bond beams are. And then our joint reinforcement, I did a blow up here for you to be able to see right there, so that you can see, because it's really hard to, but you can see we've got our joint reinforcement at 16 inches on center. You can see the white dots in that wall right there. So if we aren't in right off the bat at pre-design, and you do have some plans put together, some elevations put together for us, the design development stage, we can try to, with you, determine what wall system that's going to be, if it's going to be a single width, if we're looking at a cavity wall, if you're looking at a single width for furring it out on the interior, whatever you're going to do there, at least we can determine what type of wall system we're going to have. Our materials and selections, typically if we've got the elevations up there, you might not have the exact type of brick or a block that you're going to use, but we could talk about that, give you different material options and pricing on that as well. Code compliance, like I had talked about, I'm going to go through that a little bit more in detail, but we want to check the wall system, make sure that what type of building is it, what are we looking at, is it going to be a non-conditioned warehouse space, or is it going to be a school or a commercial building that we need to have and meet a certain R value. And then some of the special requirements that we would have would be, well, in this area, we typically would design around seismic category D or C. We'll look to see if there's any more storm shelters in the project, if there's any ballistic requirements, and then fire ratings, if there's a safety plan. If not, we can go ahead and put that in and help you determine what we need as far as the size of CMU and what we need to have grouted for our fire ratings. Verify the seismic design category. That's something that I get involved with Bruce on. So Bruce, kind of, when we get a project in, I'll take those plans and then shoot them over to Bruce as well. So Bruce will put together the reinforcement that we need in the walls. One of the things that he looks at is the seismic design category. So there's ways of determining that. I'm going to show you that here on the next slide. But when we get a plan like this, we want to take a look at what are our openings and our spans for bond beams, bond beam lentils that we would have. We want to look at the materials and the veneer. and then also our floor heights, parapets. That all goes into Bruce determining what type of reinforcement that we're going to need in the wall. And then, most importantly, when we're working on this with you, we're going to do this so it doesn't affect your critical path or your schedule. So we'll put that together, and typically our turnaround time, depending on the size of the building, is 2 to 5 days. So we try not to mess up your schedule. You continue doing what you're doing, and we'll put together the wall system for you, and then jump on a Zoom call at the end of the week, run through that information with you. And if we need to make changes, the nice part about being involved early on in the design is that we can go through, and we might change this up 5 times based on, as that design progresses, what type of veneer you're going to have, what type of wall system you want to have. So we can be making those changes all the way through to the time the construction documents are complete and it goes out to bid. So tradesman software, has anybody here used tradesman? Nope? Okay. I know we had talked about it, right? Yep. Well, if you do, we can certainly help you with that. But that's what we use, or I use, to model the projects. I call them modeling the projects, but it's basically putting together everything. The wall systems, the entire building. We actually put it on your plans, so we use that as the footprint. And then we can put together our wall assumptions that way, what's involved in the wall itself, and then the reinforcement that I get from Bruce on that. So this is what a screenshot of what it typically would look like here. And so you lay out everything. If there's a rake in the wall and we've got slopes, we can put that in. We put in, it might be kind of hard for you to see, but the outside width, which would be our veneer. Our odd course is what we have built into the cavity of the wall, and then our wire, what type of structural block we're going to be using. We get into detail on where our bond beams are located. That all depends. This obviously was a seismic design D, because you can see that we've got bond beams at 4 foot on center there. And then the reinforcement, vertical reinforcement that we have in the wall here. So once we do that, put all the information in, then we can actually lay it onto your plan. And then once we have the entire thing built, we can go through and put in the crew sizes, scheduling, any of the other scaffolding that we would need, wall bracing that we would need, so that we can come up with the total price for you. And that would be a total price at today's market price. So the other thing that we want to do when we go through and put in these models, as we go through and we look at, are there, with the plan as it's called out, are there anything that we can help you with to try to save money, and to make the wall system easier, cut down on the scheduling. One of that is the modular dimensions, better layout of reinforcement. So you can look here, this is actually showing you where these are cut block here. So you can see all of the shaded area here. That's all cut block. So now we're cutting back on the lay rates, because it's going to be, it's going to take longer for our masons to be able to get a sawman out there, cut those blocks, lay the blocks. So we say, let's go ahead and take a look at modular dimensions. Let's get everything modular. So this is one that I put together in Tradesman here, so you can see that we've got a 48-inch opening. Our doors are at 7.4. So everything is modular dimensions here, and we don't have any of the cuts. So we can reduce the schedule time and save money by not doing that. So design analysis. If we get involved in the construction document phase, which sometimes we do, like I said, it's always better to be involved early in the project if we can. But if we're in the design development, if we're in the construction document or value engineering phase, then we can take a look at other things. By that time, you probably have structural documents done. So we can do, and with Bruce's help too, do a review of the structural documents, verify the seismic design category. So we want to take a look at that because certainly it involves more reinforcement in the wall if we're in a category D. One way to do that is if you don't already have geotech reports showing us soil conditions, then we can use the ASCE hazard tool. Does anybody here use that? I'm sure. Yeah. It's really a good tool. You go in, there's 4 things that you need to have. Location, you can either pinpoint that on a map or you can put in actually a physical address. The version of the ASCE that you're using, right here. So this particular one, I did it right here at this building here, but 716, risk category of the structure, and then the soil site class. If you don't already have geotech reports showing you the soils, then by default you would put in a D, and then go ahead and put in seismic, and then you end up with a report summary here showing what seismic design category we're in. And by knowing that, like I said on the previous slide, you'll see that we have to add in bond beams at 4 foot on center for the structure in a seismic D.
Question. In your design analysis, you're not doing a peer review, you're just looking at the masonry portion is what conforms with standard practice.
Sure, yep, that's exactly what we do. Take a look at the masonry wall system, and then also, I'm going to show you a project here that was designed with precast walls, and we went in and there was a cost comparison of the precast versus what we can do it with in doing a cavity wall. Mm-hmm. And then any of the structural savings, we can go ahead and take a look at that and see if there's ways for us to cut that back on, if we're using steel, we're point loading, and we can actually if we can use a structural load-bearing masonry wall, we can avoid that point loading and then what we would have in the ground. So when you take a look at everything and compare apples to apples, we can show you what our cost would be to do that. And energy code compliance, and then the moisture resistance of the wall system. So all those things we can look at during the construction document phase, and also if the project comes back over budget or we need to make some modifications, we can do the value engineering on that wall. So code compliance. Here's a typical cavity wall system. We like to call it the premier wall. A little bit biased here, but we think this is the best wall out there. But that is a structural CMU backup. This particular one, I used a 12-inch lightweight unit. And then our 2 inches of XPS. And I say 2 inches of XPS, that's pretty common around this area in our zone. The project I'm going to show you next that we walk through is actually, we used a 3-inch XPS in that one. But this was 2. And then airspace, our mortar net, and our flashing at the base of the wall. And then we used, on this particular model, used a modular brick veneer just to show you where we would be. So what do you get out of this wall? Moisture resistance, and then energy code compliant. If we looked at this wall on the IECC 2021, I believe it's, let's see here, yeah, it's C402.1.3 in the IECC code, and that's going to show you, it's going to give you this table here. And where are we? We're in zone 4. All other right there for a mass wall. It's going to show you that the requirement, minimum requirement is a 9.5 continuous insulation. And this particular wall right here, once you go through and put that in, if you take a look at the thermal catalog that I had showed you previously, that you can go through and break it all down. It'll say, give me the density of the block, and then you go through and say, what type of reinforcement is it? Is it light? Is it heavily reinforced? No reinforcement? And then the veneer, and it'll actually pull together and give you what the R value of the wall system is. So this particular one, we were at 14, well exceeded the 9.5 minimum that we needed. Any questions on that? So here I'm going to run through, this would be typical if you were to have us give you some assistance on a project that you're working on. This particular one was in a project that we did in Iowa. There was a supplier up there that wanted some assistance with one of the architects and contractors that he was working with to take a look at a wall comparison between a precast wall and a masonry wall. This would be pretty typical of what we would put together for you and then run through a project. So we always put together a pricing team. We like to have everybody here that would be involved in it up here so that you have their contact information. Typically, we'll do a short bio for you so you know a little bit about them. This particular project, I was involved, Dave Gillick was involved. We had a supplier, which was Midland, that was Kelly, was involved in this project, and then Seahouse Masonry. So it's always nice to have a supplier and a contractor involved because then we can look at crew sizes, lay rates, material costs, and the whole team brings everything together. Once again, pricing comes first. You know, everybody likes to, nobody really pays attention, I don't think, until you show them what the pricing is on something. So we always like to have that out front. Let them know where we are. So we always say if it's in the picture, it's in the price. So this particular project was a new gym. It was an addition to an existing school up there. So it was a new gym, a new entrance, and then classrooms that they had as well. So the whole project alone on this particular job was $1.3 million. Now, might seem like a lot, might seem like a little bit. We really get involved in anything from a 10 by 10 shelter to large school projects. So really there's nothing too small for us and nothing too large. We can put that together for you. Scheduling might just take us a little bit longer on our larger school projects. We like to show in this, like I said, this is a PDF that after we were done with this and after we were done with a quick presentation to the contractor, I'll make a PDF and then send it out to everybody. This is probably something I know, Paul, we've worked on, other people in the room, we've done projects for you. So you're used to seeing this, but for those that we haven't, we put together everything for you so that you know when you get the pricing from us, what was included in that, what plans were we working off of. And so we put these in as notes. This is what this particular job was, a 2006 IBC and IECC. So a little bit older than what we're used to here. Show that we used the TMS 402602. No material taxes were used on this. It was a school project. The pricing that we used was at that time from the subcontractor level and actually from Seahouse, who we were able to get our crew sizes and our pricing from with our lay rates. And then limited structural analysis on this one, and no steel angles were included in the project. So you know exactly what we were working off of. So if we need to go back during the design development stage and make changes to it, we'll make changes as we go. If some of the information that the contractor may see or the architect may see at this point in time, we can always make changes to that and then modify our pricing. This is a site plan. We always like to show this because it gives us an idea how we're going to stage the project also. So we can see that this particular project, the existing school here. So I just do an overlay for you just to make sure that I'm right in this so that we know where all of our materials are going to go, where we're going to stage everything. And then this is the new addition. So this is what we'll be pricing here. This was the elevation that we had and the rendering that we had from the architect. And then these were the plans that we worked off of. It was early on, so we didn't have a lot of the details. So these were talked through with the architect and the contractor at the time. But it's very early on. Here were some of the elevations that we had showing our wall heights, where we needed to be for the gym, our wall heights and openings that we had for our entrances and our overhead doors here. And then a couple of sections through the building so we could see and determine what some of our interior partitions heights and wall heights were going to be. I show this because, like I said, this may change. If it's early on in the design, things may change through here. So if you look at the pricing, you want to make sure that you know exactly what we were pricing off of at that time. Here is the model that I built. It's just an overhead shot of it. So you can see in Tradesman, we put together all these walls here. And then some of the interior partitions that we had. This really basically started out as a project where we were going to take a look at the gym, because the gym was precast panels on this. So it started out with that, and then I built everything else for him to see where we would be on the masonry end of it. So here are the gym wall assumptions that we had. It was a 12-inch backup CMU, structural walls, veneer, utility brick that we had on here. There was another, this actually was just a portion, there was an interior side of the building right here. So you see where we stopped the veneer on this point. 3 inches of XPS where this was located, even though you'll see 2006 IECC called out, it was only a 9.5 at the time. And this is in zone 6. So now, if you look at the current code, I think we're at, let's see here. We were at 13.3, which we would have had to have met 13.3 if we were doing it today. 2-inch airspace, more net and flashing, like I said, at the base of the wall, so you can see all of this. If it's in the picture, it's in the price. Reinforcement, one number 6 at 32. And then where our bond beams were, 10 foot at bearing and at top of wall, and then our joint reinforcement in the wall. This was for the gym itself. The other wall assumptions were 8-inch interior walls and 8-inch exterior walls that we had for the classroom side of it. So same thing, utility brick, and the same makeup of the cavity here. And then our reinforcement changes because we're at shorter walls here. So we were at 48 right here. One number 5 at 48 rather than 16 on the large gym. So you can see all the different walls that we have in this section. Some of them interior and then exterior.
Question.
Yes?
Sorry to bother you, but
No.
understand when you submit this document back to the designer, you've got rebars and everything identified. You haven't analyzed it, vary the loads or something, right? Structural engineer still has to do his due diligence.
Yeah, we aren't the engineer of record. But what we do is when I get those plans, I can get together with Bruce, and Bruce is our structural engineer in-house. So then we take a look at the wall. Bruce will take a look at the loads and then be able to determine what we would need in that wall for reinforcement. If we don't have that already from the structural engineer, we'll take a look at that. And then if we do have it from structural plans, we can also take a look at it and say, hey, do we need that much reinforcement? Maybe it's over reinforced. And so we can take a look at that as well. We certainly aren't trying to do the job of the engineer, and we aren't stamping the plans, but we're able to give them the information that we have come up with. And then maybe if that differs from what the structural plans show for reinforcement schedules, then we can talk that through, and maybe we can save some money by not having to put the reinforcement in the wall. So this is the tradesman model. So this is what I built, which is showing the addition to the gym and the classroom and the new entrance. A little bit more of an overhead so you can see some of the interior partitions that we have in here as well. And also, like I said, we do color coding so that we show where our bond beams are located. So you can see our bond beams at the top of the wall. This is a bearing here, and then throughout the wall what we needed structurally. So you can see where those bond beams are located. And also, I'll talk a little bit about this coming up here because you'll see that reinforcement, but you can see over our openings, over each of our openings here, we show the use of bond beam lintels so that we don't have to use a steel lintel. We can keep the material the same, and then we don't have any issues with two materials acting against each other. This is where the addition was. So you can see we're basically going up and against an existing gym here. So you can see that this is really wall to wall here, so we don't have the veneer. Our veneer starts up here on this particular wall. And then we talk about the reinforcement. So we can pull everything off. We can pull the insulation, we can pull the veneer off so that you can see where the reinforcement is that we have in the wall. And it gets pretty particular. You actually put in lap splicing, you put in the size of the bar, how many bars are in each cell. For our bond beam lintels, Bruce will take a look at that. Bruce and I just got done with the project, or we're actually working on it right now, but where are we at? 50 foot opening?
Yeah.
For the stage, it was a stage opening, and we had a 50 foot opening there that we were able to use bond beam lintel on. It was 8 courses, so you definitely have to have that height there above the opening, but it was 8 courses and we got it to work. It was 2 number 5s, I think, in each course, right? Mm-hmm. Yep. So you can see where we are with our lap splicing too. So it gets pretty detailed in this, our horizontal reinforcement, our bond beam lintels, our jam bars here, and then also the lap splicing, and you can see the difference of that in compared to the gym where we're at 16 inches on center versus 48. So there's the whole building right there with everything taken off just for the reinforcement, so you can see what we included in there for our reinforcement. If that has to change during our design time, we'll go through and make modifications to that. And as the structural engineer gets involved, we talk to the structural engineer quite a bit in the plans and projects that we work on. So if we get involved in that, we can talk through that. And if there's some savings there and we can take out some of the reinforcement, that's great. Yes?
Do you guys lay out joints too, or help with that?
Control joints? We do. We do. I didn't on this particular project because I was just trying to get this out. But I think we did a couple of modifications to this and revisions. And I think at that point in time, we started adding in the control joints. And then you can see the reinforcement that we have built in there on the control joint. Mm-hmm. And that's also something that Bruce will get involved in, and where the location of those joints are. And we'll try to do a minimum, and then we'll do it at openings as well. The other thing we take a look at is the stem wall. And this is something that we try to include on every project that we work on. And so with this particular job, we've got our stem wall for our 12-inch unit, and then our stem walls for our 8-inch exterior. So this one, frost levels were lower than they are in St. Louis, so we are actually 1, 2, 3, 4, 5. So we're at 40 inches here, and we use this is our 8-inch CMU wall. So our 8-inch exterior CMU wall goes right here, and then we've got our 3 inches of XPS. So this insulation then goes from the top of the wall all the way down to the footing. So it's continuous insulation all the way to the footing. So in most cases, you would see that they would have run their insulation up against this wall and underneath the slab here. We keep everything outbound all the way down to the footing by using the stem wall. And then we have a 6-inch unit on the outside of that insulation, and that would be for our airspace, and then our ledge for our 4-inch veneer. The reinforcement is the same. Everything below grade is grouted solid, and our joint reinforcement below grade goes to 8 inches on center. Same thing for our 12-inch. We've got our 12-inch, our insulation, and our 6-inch here. So you can see this is below the plan. So you can see where the stem wall is that we have built in here. And this is all looking up underneath. You can see the insulation where we have our bar and our stem. And then the full stem and pricing. So pricing on this one was at $220,000 for the stem. And then in total now, with the building and stem, we're at $1,528,000. And that's with the veneer that we had chosen. I think at this point, I think this was very early on, so we try to match the colors as much as possible. That's where the suppliers come in, and they can get involved in what type of materials do you want, what type of pricing do we have for those materials, and that's everything that we put together with the contractors as well. So when we're putting these numbers together, we want to be as accurate as possible when we come out to you. then that's all at today's pricing, market pricing today.
You also include the bracing for the down walls.
I'm sorry?
You include the bracing for the down wall, like
The wall bracing?
Yeah.
Yes, actually in that tradesman shot there that I gave you, when we set up the wall system, we put the wall bracing in there, at 20 feet. And then we've also got scaffolding built in. We've got mock-up panels built into that. We've got freight built into that for the materials, anything that we would have. And that's why we have the contractors involved also, so that when we put together the numbers, they're true numbers once it comes out to you. So we want to have everything included in that system. This, like I said, was the 2006 IECC. So when you look at this in the table in the 2006, at this point in time, when we did this project, the 6, in zone 6 where this was, like I said, it was in Iowa. So we were at 9.5, which, like I said, now I think it's at the 2024 IECC, I think has it at 13.3. But even at that, once we pull this together, this is that thermal catalog that I was showing you. So it says the assembly, continuous insulation in the cavity and 4-inch concrete masonry veneer. Okay, so it shows you what we're having in the wall here. And then we go through and list it out. So we've got normal weight block. This is for the 8-inch here, lightly reinforced, and this is for the 12-inch, lightly reinforced. And our numbers are at 18.84 and 19.01. Now, this particular one, I think we said we were using a modular brick. So in that modular brick, they'll show you in the thermal catalog that we can take a 0.5 off of that. So we're over 18 on both of those walls. So far exceed where we need to be for the R value. And then moisture control. This is something else that we can show you. This would be much like one of our mock-up panels to show you that we've got our structural backup block, 8 and 12. We've got our flashing system here, our insulation, our hook eye for our connector to our brick, our fasteners, our mortar net, and then our veneer and weep vents in the wall. So it shows you everything that's included in this wall system. And what we can do also is we can do dew point analysis. I don't know, most of you do dew point analysis on your walls? And that's something that Duke back there can help us out with, right, Duke? That's right. So this shows you here in these dew point analysis, this is your 8-inch block. This is your insulation, your airspace, and then your brick. And it has at different temperatures so that you can see where this occurs. So at this particular one, we can see that our dew point occurs right in the airspace of our wall, which is exactly where we need it to be. So we can do that and get these calculations for you as well. The other thing that a lot of people didn't know, this contractor didn't know this at the time, and I think we were able to save a little over $5 a square foot by this here. And this is part of the energy code, same chapter as the R value table, but it basically says that 1 coat of block filler or 2 coats of paint on your masonry wall meets the air barrier compliance. You don't have to have an air barrier if you do that. So he was able to save almost $5, or a little over $5 a square foot on the project. And that is in the same chapter as the R value table that I was telling you about in the IECC. So that pretty much wraps up what we would do on the presentation side of it. And then, that's something, like I said, once that's over with, and we do a Zoom call. Typically it's a Zoom call. We can do it in person, but Zoom calls, they don't take up nearly as much of your time. It takes about 20 minutes to run through a project like that. And then we'll make a copy of it in a PDF form and send it off to you, so you have that to take a look at. Typically we like to do that at the end of the week, depending on the size of the project. But this is really what we try to follow with on all of our projects, and that is collection and review of the documents. Can we add value? Very, very rarely can we not add value to a project. At least be able to put that pricing in front of you so that during your design stage you can take a look at that and compare it to other wall systems. If you're looking at other wall systems, at least you have all that information in front of you and can make those decisions as you go through the design. Oh, sorry. Then we are engage. If we know that we're going to be building a model on it and doing that for you, then we want to get a contractor involved, get a supplier involved. I'll call Chuck, talk to him about it. You know, he's Midwest Block or Best Block, and talk about, you know, any of the supplies, any materials that we would have on the project. Get the mason contractor involved, a local mason contractor. Structural analysis. Bruce, like I said, would typically take a look at the project once we get it, and then go into the design cost, which is putting everything into the tradesman and making that model and putting together the total pricing. Then we put everything together into a PDF or a PowerPoint display here that I'll run through with you. We like to do that at the end of the week, and then I distribute all the documents back to you so you can have that, refer back to it. As that plan changes, we can make modifications to it, and that's why we try to stay involved in the project from early on all the way to the point where it's bid out to local contractors. So, quick turnaround time. Like I said, we're probably 2 to 5 days on projects, 5 days being the larger schools that we're going to put together, all the interior partitions, storm shelters. Those take a little bit longer. PDF documents for review, and then revisions as we go through. It's always like we say, if it's in the picture, it's in the price. So when you have that model and you see everything together, what we based it on, the plans that we based it on, that's the price. So optimizing masonry, like I said, stem walls, something I think everybody should consider here. Take a look at that continuous insulation all the way down to the footing. You can see that here below the wall, the stem wall, and then you can see it here. This is right at grade. So you can see at a door opening, we actually have our insulation going all the way down the footing. And then some of the technological advances, I don't know if anybody has been out to one of our hands-on. Allison does a hands-on in the spring, a couple of days. You can go out there and build the wall, see some of the equipment. The mule is one of those things that's out there. It's nice. This is the mule, so it's a material unit lift enhancer. I actually had to look that one up because I didn't know what mule stood for. But yeah, so I don't know if you guys seen the mule in action? No? Rudy, have you been out there? You've been out there for hands-on, haven't you? Has it been a while? Okay. But they actually have one of these out there. So you can see what this does is a robotic arm basically that comes down and it takes a hold of that right web, the block, and it takes it down to a pound. So if you're using a 32-pound block, it basically takes it down to a pound. So you can just swing that, put it in place. It actually drops it, releases it, comes back up, and you can keep doing that. So you can use larger units here. That's a 32-inch unit. So some of our bigger box stores and buildings, warehouses, and you don't have a whole lot of openings, you can pretty much fly through a wall like that. So you can see he's doing that right here. So if you sign up for the hands-on, you'll be able to use that out there. So that was one of the first pictures that we had loaded up here. I was actually showing that on a mock-up wall that we had. And then, so some of the masonry options, materials and sizes, up to a 32-inch block. You know, Chuck can certainly help you out with any of that, suppliers. And if you want to go through the suppliers, and the suppliers can get a hold of me too, I can help build out those walls for you. Some of the architectural blocks that they have out there are acoustical blocks that we use in theaters and in schools. This one was Reed Springs, right? Reed Springs wall here, and you can see some of that architectural block that was used. And then consideration and advantages of using masonry, and then use it for all it's worth. If the masons are going to be out there, it doesn't make any sense for us to be doing a precast panel that we've got to wait for 10 weeks on. We can go ahead and get in the ground right away, start building. And then we'll give you a schedule for that too, so we know how many crew days it's going to be able to put that wall up, when you can get under roof and then be finalized on the plan. Why take advantage of MSC services? Helps to provide structural masonry walls. We won't affect your schedule. We'll work right alongside you. No hard sell. Come to me, I'm not gonna keep calling you. I'm not going to keep bothering you. I'm going to give you the information that you need. We're here as a resource for everybody. So we just want to give you the information you need on the masonry wall system, and so that we can help during your design phase. And then the best thing, it doesn't cost you a penny. So everything that we do is paid for through the industry. So it's free of charge. So it's really, to me, it's a no-brainer, but I like to just give you the information that you need to move forward and make the right decision on your wall system. And then we've got new websites. So we've got new websites for Masonry Center, the Contractors Association, and MSC. I put a code there. It's in your pamphlet as well. So visit it. It's great. Gives you some information and our contact information also. So if you have any questions, have any projects you want us to take a look at, please do. My office is right here in the back corner, and then Bruce is right across the hall there. So if you have any questions on structural or take a look at any of your projects and help you out with the wall systems, that's what we're here for. So that's it. Wrapped up.
Thank you, Greg. Does anyone have questions? Oh, we got Phil.
So in general, you mentioned control joints earlier, and every wall is different, but generally, if you double your bond beams, you get enough horizontal steel in the wall to eliminate the joints. Is it worth doing that from a cost standpoint?
I'm going to ask the two engineers in the back to help me out there a little bit. For a cost standpoint, we would probably take a look at it both ways for you, but you're exactly right. You can eliminate the control joints in certain walls depending on the amount of reinforcement that you have, correct? Okay. And we can do it both ways and show you what the cost difference would be. That would be something that would be pretty interesting to see, depending on the size of the wall and how many control joints we would have in that particular building. If we were to do a gym, not a whole lot of openings in that, where are our control joints located minimum, and then use that and see where we are with the reinforcement difference and what the cost would be. You bet.
What are the benefits for running the installation down?
A continuous insulation all the way down to the footing, and then we also have our ledge there too. So our 6-inch unit, we've covered the entire wall, and we have the reinforcement. We can take that all the way down, and then it's not a poured wall. We can also use the masonry. Once again, masonries are out there. You might as well have them put that and take it all the way down to the footing, and then it reduces the amount of insulation that you would have under the slab as well. Mm-hmm.
Any other questions?
Cuts out the pore, too.
Oh,
What's that?
Cuts out the pore.
Yeah. Mm-hmm. Cuts out the pore. Mm-hmm.
one more?
I believe we did that on one of your projects as well. Mm-hmm.
Did your example project actually go you need masonry?
Yep. He made the decision to no precast panel on that. It was all masonry job. Mm-hmm. Part why I showed it to you. Any other questions? No? All right.
All right, before we do our drawing, I do want to remind folks that we still have 2 seminars this year. So if you're lacking in credits or know someone in your office who is, please remind them that they can come next week for a presentation, an engineering presentation on the inherent resilience of concrete masonry, or on the 17th to come and learn about masonry material testing from SCI. So I think that's going to be incredibly enlightening as well. So we hope to see you throughout the rest of the month. But Greg, you want to pull? Kenneth Hughes, Robertson Fire Protection District, coming up. All right, folks, thank you so much. And again, as you're getting your transcripts and certificates ready, if you need anything at all, give me a call, shoot me an email. We'll get you everything you need. We want you to get credit for every single minute you've been here. All right, thanks, folks.
Thank you. And a lot of people don't.
Hello.
How
we doing?
To be able to show everybody what we can do. And we've worked with a lot of guys in the room. I mean, like I said, it's.
He knows what he's
5
talking
years,
about.
We've got a little over $100 million worth of masonry work that we've assisted with. Yep. So anything that I can help you with, whether it's just